Here we need to transform the Cartesian coordinate -1, negative square root of 3 into its corresponding polar coordinate. Now let's first plot this particular point on the Cartesian plane with the x and the y axis. We can see here that both the x and the y coordinate are negative. So that means the point is going to lie on the third quadrant. Now let us suppose that this is our point P and it has the coordinate -1, negative square root of 3. So it is -1 unit along the x-axis and we have negative square root of 3 along the negative y-axis. Our goal is to convert this to its equivalent polar coordinate. For that, let us begin by first joining the point P and the origin. So here we have to find out first the value of pu. This is nothing but the radius arm. So all we have to do is take the square root, and underneath the square root first we will take the x component, which is -1, we'll square it and then add it to the square of the y component, which is negative square root of 3, and then this is going to give us a value equals to 2. So we have found out the value of r. The next goal will be to find out the angle. Now all we have to do is from the point P we're going to drop a perpendicular on the x-axis. Let's say the perpendicular meets the x-axis at point O. This gives us a right angle triangle PAO, right angled at A. So we will use this triangle. So in triangle PAO, we're going to first compute the value of angle phi. We'll come to the theta later. So this angle phi, first what we'll do, we'll take the tangent of that angle phi. This will be equals to the y coordinate, which is AP, divided by the x coordinate, that's going to be AO. And we're only going to consider the magnitude. We're not going to consider the sign. So that means AP value, which is going to be square root of 3 divided by AO, and that's going to be 1. So this gives us a value for tangent of phi equals to tangent of pi over 3 radians, because tangent of pi over 3, that gives us a value square root of 3. So equating both sides, we get pi equals to pi over 3 radians. But our goal here is not to find out the value of angle phi. We need the value of angle theta, which is always measured with respect to the positive x-axis. So that means this could be either this particular angle theta, or it could be either measured in the clockwise fashion. This could be the other case. So how to find out the two angles? So let's first find out the angle going in the anti-clockwise fashion. So here in this case, the angle theta, that can be defined as, first we, let's say starting from the positive x direction, we move a angle of pi radians. That means we reach the negative x-axis, and from there we're going to move another phi angle, and that's going to give us the angle theta. So that means theta value comes out to be pi plus pi over 3 radians, which is 4 pi over 3. The other way around will be, so we're going in the anti-clockwise fashion. So here let's say we move a pi angle, and from there if we subtract the angle phi, this is going to give us the angle theta. So this is pi minus theta, but since we're moving in clockwise fashion, so we'll have to consider the negative value of theta, and this comes out to be equals to, so we have pi minus pi over 3, which is 2 pi over 3, so we get negative 2 pi over 3 radian. So there are two possibilities. Theta could be the 4 pi over 3 if we move in the anti-clockwise fashion, and if we move in the clockwise fashion, then theta value will be negative 2 pi over 3. So now we can finally express our point P in the polar coordinate. So this could be expressed either in the form 2, 4 pi over 3, or the other way around will be 2, negative 2 pi over 3 radian. So that's completely your choice, whichever you want to choose according to the given conditions.